Are we okay with the voice? Are we okay with the voice?
Yes, Mister.
Yes, Mister, the voice is okay, but please open the chat box.
Okay. Okay. So we are going to start directly. We are going to start directly whatever we have stopped at. Okay. So I'm going to be a little bit fast today. We need to finish a certain part, since that part is going to be included for your quiz. Okay. The second thing, for your quiz, it's going to be next Sunday. I have already told you. And then previously I was telling you that you are supposed to be opening your camera. Now you are not asked to open your camera. Okay. We have received today a commentary that it's not required. So you're not supposed to be opening your cameras. Okay. That's for your test. Now returning back to whatever we have started. Okay. We try to solve this particular problem, if you remember. This is what we supposed to be finishing last class, but we have solved one of the one-way SLAB problems since you have asked me to solve it for you. Okay. We started this problem, if you remember. We checked whether it's a one-way SLAB or a two-way SLAB. We got the Ly divided by Lx ratio. You can see here 4 from center to center and then 5 from center to center. So 5 divided by 4, and we have got our Ly by Lx ratio. After that, we checked the support condition. We said for a two-way SLAB, we have two cases, either simple or restrained. Restrained is the big table. Simple is the small table, if you remember. Okay. So it has been said clearly here that it's restrained, and beams and slabs are brought together. Slabs and beams are brought together. Material properties, it was given that the grade of concrete is 335, and then the grade of steel is 460. Okay. After that, we went for the durability conditions, and we said based on the question, we are going to check whether we need to find the cover. When we talk about durability, mainly we talk about the cover and the minimum dimension. Okay, we talk about the cover and minimum dimension, which will protect our steel. And we said the steel should be protected from either water or fire. It should be protected from either water or fire, or both of them. In this scenario, it says for us design the corner slab for mild condition only. So they have mentioned for us the water condition, the moisture condition, but they didn't mention for us the fire. So we only need to check for water cover. Okay. Now I have already told you what is mild, moderate, severe, very severe, most severe, and aggressive. So I'll not return back to it. So basically the question is asking us to go for mild. Now we have mild and grade of C35. So we have mild, grade of C35, and the proper cover to be chosen is 20. Okay. Doing that, we were able to find our cover. Okay, so the cover is now 20. Okay, the cover is 20. We need to go for the next step. Okay, we need to go for the next step. The next step after finding your cover is going to be estimating the depth. So if the depth has been given already, you don't need to estimate. Okay, if the depth has been given for you, if D small or D capital has been given, you don't need to estimate. You need to go and calculate the effective depth. Now, if nothing has been given, you need to go and estimate. Now, if we return back to the question, in this question, you will see that the depth of the slab has been given. The overall depth of the slab has been given. It means I don't need to go and estimate how much is the D small or how much is the effective depth. In the previous method that we have solved, or the previous question that we have solved here, you remember that there was no depth given. Okay, there was no depth given, so we had to use this equation to estimate how much is our depth. Okay, so if the depth is not given, only at that time I'm going to use this equation to estimate. Okay, choosing the proper span, modification factor, and then ratio. Now, in the question that we are solving right now, the depth has been given. It means that I don't require to go and calculate it using, or try to go and estimate it using the equation. Okay, using the equation of D small is equal to span divided by modification factor into ratio. That's an estimation of the effective depth. Now what we need to do, rather than estimation, we need to calculate because D capital was given. Okay. So what we are saying, if this is your Lx and this is your Ly and this is a two-way slab, we have checked that this is a two-way slab, there will be reinforcement parallel to the x direction. Okay. There will be reinforcement in white color parallel to x direction. We call this reinforcement, the white color, we call it as reinforcement of x. Okay, we call this one as reinforcement of x. So at the bottom we have reinforcement of x. Above reinforcement of x, we have another reinforcement which is having a black color that is parallel to the y direction. Okay, parallel to the y direction, and we call it y reinforcement. So we have x reinforcement and we have y reinforcement. X reinforcement is parallel to x, y reinforcement is parallel to y. X is in white in this example, y is in black. Are we okay till now? Are we fine? Okay. Okay. So now if I go and see, if I try to take a section saying it's from here, okay, what I'll be able to see, I can see that there is bar number 1, number 2, the black colors, 1, 2, 3, 4, 5. I can see many black colors, okay, but I can only see one white, and the other ones are not going to be seen because they are behind the first one. Okay, so if I go and see it, I'll see the white color. The other ones I'll not be able to see them. Okay, but I'm going to see the black in this way. Are you able to imagine? Okay, so we have the white color. Which is the reinforcement of x, if you remember, and then we have the black color, which is the reinforcement of y. Now, what do we need to get? If you remember, last class we have taken a zoom section. We said we have something called D capital, we have something called dy, and we have something called dx. We said in case of a two-way, then we have dx and dy. We said in case of a one-way slab, we have main reinforcement, and the top one, the white one, if it's a one-way slab, the bottom one, which is white, is going to be as main reinforcement, and the black color is acting as a shrinkage or a minimum reinforcement. Okay. Now we want to go and calculate. Already we know that the overall depth has been given by the question. Okay, we should know that it has been given by the question, that the overall depth of this particular slab is 175. Okay, so if we have 175, dy we know it's a distance from the top fiber to the center of reinforcement of Y. dx is from the top fiber or top compression fiber till the center of the X bar. Now we need to see the equations to calculate dy and to calculate dx. Now we can see dx is going to be equal the overall depth. Okay, dx is going to be equal whatever overall depth is there minus we need to remove the cover. So I'm removing the cover from here. So we have D capital, we have cover, and then we need to remove half of the bar, half of the white bar. Are we clear? Are we fine? Yes, Bushra, what's not clear? My dear, the cover, we just got it before 1 minute. We have just got the cover from here. Okay. So that's the cover. And then we have half of the reinforcement. Now going for dy, if we try to find an equation for dy, okay. Now we have cover here and we have cover here. Now we have taken half of, for x, we have taken half of the white bar, but we need to still take the other half of the bar. Okay, the other half of the bar. And then we need to take half of the black color. This is my first reinforcement. This is my second reinforcement. Now the distance from here to here is whatever we call it as dx. dy is a distance from the top till the center of this one. So if I want to calculate dy, then dy is equal to dx, dy is equal to dx minus half of the white color minus half of the black color. So minus half of x minus half of y. Normally the diameter, when it comes to two-way slab, normally the diameter of x and the diameter of y are going to be the same. So rather than saying diameter of x divided by 2, diameter of y divided by 2, I can go and say that dy is equal to dx minus 1 diameter. Are we okay? Are we fine? Okay. So if we go and see the equation now, let me just try to delete. If you see, okay, if you see, we can say that dy is equal to d minus cover minus half of the bar minus half of bar of x minus the other half of the bar. So it's like half of the bar minus the other half of the bar minus half of the bar of y. Okay. Now this part which is d minus cover minus half of the bar is whatever we called it as dx. Okay, this is d capital minus cover minus diameter over 2. This is whatever we called it as dx. So if we want to calculate dy, then dy is equal to dx minus half of the x bar minus half of the y bar. And we say they are the same, then I can say it's dx minus 1 diameter. So if my dx is 150, so it's 150 minus 1 diameter, diameter is 10. So 150 minus 10 is going to be 140, whatever you see here. If the diameters are not the same, then you need to have dy, let's say dy is equal to dx minus half of the diameter of x minus half of the diameter of y. This is going to be used in case of your diameter of x and y are not the same. If they are the same, half and half is equal to 1. Are we fine? Okay. So we have got our dx, we have got our dy. The next step is to find the bending. Okay, the next step is to find the bending. Now, if you see this was, okay, this is my slab, and they said it's a corner slab. So we are referring to this slab. So we are taking this slab and we want to draw, because it's a corner slab, we want to draw the bending moment for it. Okay? So we are going to go for a slab. Okay. So you can see that this is disconnected from here, and then this is disconnected from here. And now you should be able to know how to draw the bending moment diagram for slabs. You can see that your bending moment is in this shape. Do you agree? In two-way slab, both of them are main. This is what I was saying. In one-way slab, it's only one main bar. In two-way slab, both of them are main. It's main X and main Y. Both of them are main. We don't have something called main in two-way. We have dx and we have dy. Both of them are main still. Are we okay with the diagram? Once again, I replied, Amia, I told you if the diameter of x and y are the same, you can take one bar. If they are not the same, you need to take half of the first one and go for the second. Okay. So now what do we have? We have here x positive, because this is for x. We have x negative, we have y positive, and we have y negative. This x naught and y naught are representing 0, right? X naught and y naught, you can see that the bending moment value is 0, right? Okay. Where is the mistake?
Sir, dy equal to capital D minus cover minus the diameter of x bars by 2, or what? x bars by 2 minus y bars by 2.
Okay. Now, once again, this one is dx. Very clear that it's dx. Now, this one is not dx. There is a difference between half of the bar and a full bar. Okay. Now, if you want to use whatever you are saying, then it should be dy dx minus half of the bar of x minus half of the bar of y, or I can say that is going to be d or d capital minus cover minus half of the bar of x. This is going to be representing for you. Let me open for you. Otherwise, it's going to be too much. Okay. So we have dx. We have dx equal to d minus cover minus diameter of x over 2. Okay. Over, and I can say that dy, okay, dy is equal to d minus cover minus diameter of x over 2. This is whatever we refer to it as dx minus the other half of x minus half of bar of y. Now this can be written as dx minus half of the bar of x and half of the bar of y, or it can be written as dy equal to d minus cover half and half is going to be 1 bar minus half of bar of y. These are the same. And this is what's available here. Are we okay now, Amira? Okay. Okay. Now, do you agree with this bending moment coefficient? Others, are you fine with the bending moment coefficient? We were saying it from the beginning. We were saying that dx is still half of the bar of x, dy is still half of the bar of y. We said that. Okay. Now, if the coefficient here, if the coefficient is equal to 0 in x naught, and the coefficient, if the coefficient is equal to 0 here and the coefficient is equal to 0, our moment equation, we said it's equal to beta multiplied by w multiplied by L square of x. Now, is it possible that L can be 0 in this scenario? Here we have the bending moment in this scenario. For x naught, the bending moment is 0. For y naught, bending moment is 0. So it means either beta is 0, or w is 0, or Lx is 0. Otherwise, you cannot get the bending moment to 0. Lx, how much is it? We have Lx to be 4, so this cannot be our 0. W cannot be 0 because there is a self-hold. So this is not the one which is 0. So if I asked you, what is the beta here? Your beta should equal to 0. The coefficient of bending moment for x naught and y naught is equal to 0. That's why the bending moment is 0. Are we clear? Okay. Now you see that there are four values. There are four values to be calculated. We need to get we need to calculate x plus, x minus, y plus, y minus. Okay, because x naught and y naught are equal to 0.
Sir, I have a question.
Yes.
Sir, for the previous question, you solved it in Sunday. They said calculate the maximum bending moment, and here also required to calculate the bending moment, but there we use different method.
Yeah, because that was a one-way SLAB. This is a two-way SLAB.
Okay, so here we use case 4 and we find the coefficient.
We'll see which case now.
Okay.
First thing I told you, the first thing that I have done when I solved this question is to find Ly divided by Lx, which will give me which type of slab is it. Is it a one-way slab or two-way slab? If you have done that mistake from the beginning, then everything is going to be wrong. Okay. Now, if we see here, this is which case? This is going to be the case of two adjacent edges discontinuous. It is where one long edge discontinuous and the other short edge is discontinuous. We have already went through this. Okay, we already went through this. Now we have Lx to be 4 and Ly to be 5. If we try to get our Ly by Lx value, 5 divided by 4, this is going to give you 1.25. Okay, 1.25. Now the first thing, if you remember, we have the values of x and we have the values of y. So we have values of x and we have values of y. Now for y, we have 0.0445 and we have 0.034. One of them is negative, another one is positive. So we have this one negative, we have this one positive for y. So now I can say that my beta y negative is 0.045. My beta y positive is 0.034. Any questions till now? Okay, now can we calculate for x? Can we calculate for x? You can see that we have Ly by Lx to be between 1.2 and 1.3. Okay, it's between 1.2 and 1.3. So what we need to do, 1.25 is exactly in the middle. Okay, 1.25 is between 1.2 and 1.3. What we can do, I can calculate beta x negative by taking the average of 1.2 and 1.3. Because the average of 1.2 and 1.3 is going to be 1.25. So we have taken 0.063 plus 0.069. Here it's a mistake. So this is going to be 0.069 divided by 2 is going to give you 0.066. So this is our x negative now. For x positive, the same thing I'm going to do. It is 0.047 plus 0.051 divided by 2. So we are going to get it as 0.049, and this is representing your x positive. Are we okay till now? Are we fine till now? Okay. Now next step after finding the coefficient. Which step, Bushra? Which one is not clear? No need for interpolation if it's half, Suleiman. If it's half, it's direct. No. If it's 1.43, 1.22, 1.51, 1.62, if it's not exactly in the middle, you need to do interpolation. Once again, Ly over Lx is equal to 1.25. So we have here for x, we have 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.75, and then 2. For y, we have one value for all the cases, for whatever Ly by Lx value. So for us, we can directly find our y negative and y positive, because it does not depend on the value of Ly and Lx. So we can say that the negative moment in continuous edge is going to be 0.045 for negative y, because these are these coefficients for y. And for the positive, it's going to be 0.034 for y as well. We have got y positive, y negative. Now for x coefficients are depending on the ratio of Ly divided by Lx. Okay. Ly divided by Lx. In this scenario, Ly divided by Lx is going to be 5 divided by 4, which will give you 1.25. Now, unfortunately, we don't have direct values for 1.25. We have only 1.2 and we have 1.3. So either you do interpolation, or since it's exactly in the middle, we are going to take the average. Both of them are going to be the same. Okay, so here for 1.2 it's 0.063, for 1.3 it's 0.069. So the middle is going to be how much? We have taken the average of the two and we have got the value. So that is for half over 1.25. The same thing we have done for the positive bending moment. We took the value of 1.2, we took the value of 1.3, and we have divided it by 2. Are we clear? Okay. Now for interpolation, if there is time at the end of the session, I will try. Okay. Now, after we have got our coefficient, now the next step after we find our coefficient. Yes, they are not contradicting each other. So if interpolation is contradicting the average, then nobody will use the average. Okay. So now for the bending, we have already said that our moment equation is equal to beta W into Lx squared. Now we know what's our beta. We have got it from the previous slides. We know what's our Lx, which has been given in the question. The remaining thing for us is the value of W. Okay. So now we need to calculate our W. Now to calculate our W, if you remember, we said W will be consisting of dead load and live load. Dead load will be consisting of self weight and finishes. Dead load to be multiplied by 1.4. Live load is to be multiplied by 1.6 according to the combination. Okay. Now if we go and see the equations, we can see here, you can see that we have 1.4 that is for the dead load, multiplied by the self weight. Now, how to calculate the self weight? How would you calculate the self weight? Do you remember how to calculate the self weight of the slab? Self weight of the slab. So the self weight of the slab is to be calculated as 24 multiplied by the depth of the slab. What is the depth of the slab in the problem? We return back to the problem. You return back to the problem. You will see the depth of the slab. The depth of the slab given is 175. The dead load has been given as 6.2. The live load has been given as 2.5. So if we return back to wherever we were, you can see this is the thickness, which is 175. So 175 divided by 1000, because 24 is having a unit of kilonewton per meter cube. It's a unit weight, while 175 is in millimeter. So we cannot multiply them together. We cannot multiply meter by millimeter. So now what we need to do, we need to divide this one by 1000. So it's going to be 0.175. So 24 multiplied by 0.175. This is representing your self weight. We finished from the self weight. The second one is the finish for the dead load. The dead load has been given by the question to be 6.2. 6.2. The live load has been given by the problem to be 2.5. I just read them for you. Is it clear? Is it clear whatever I have done? We have done it in the last class as well. Okay, so we calculated the value of W. Okay. So we have now, we said the slab as well. The slab is to be designed for 1 meter width. And we have our final result as 18.56 kilonewton per meter. 15 or 18.56 kilonewton per meter. Now, can we use this equation? Can we use this equation now? Since we have W or N, can we use this equation? Okay, so very good. Now what we need to do, our betas, these are our betas, right? Beta x naught is 0, beta y naught is 0, and these are the betas that we have got. Do you agree with me that these are the betas? This equation, yeah, this equation. Okay, now can I have them in this way? Can I say that the moments are these, where we use the coefficient 0.066, we use our W, which is 18.56, and then our LX, which is 4. Are we fine? Any question regarding this? It's a direct multiplication. Any question regarding it? Or are we okay? So we are okay. Now, why do we calculate for moment? Why do you calculate for moment? Why is it important that we need to know the moment value? We calculate the moment value to know what exactly. As Zahra, we say it's always the dominant. If you remember, we said it's always LX. It is always the LX. Whether you are calculating for Y or you are calculating for X, the length is always taken as X. I have already shown you in the code, right? I showed you in the code regarding LX and L1, the betas, the moment. Did I show you? Very good. Now we need to go. Most of you have said the correct thing, that we need to calculate it for the reinforcement. We need to get the value of moment. So later on we'll be able to get the reinforcement value. That's the most important thing for me. Okay. Now if we see here, these are the equations. Okay. These are the equations that are normally used. Okay, so these are the equations that are normally used. We have K, we have Z, we have AS. So K, Z, AS, these are to be used. Our main desire is to calculate the value of AS. Okay, is to calculate the value of AS. So if we go here, our AS is equal to M divided by 0.95 FY into Z. By the way, since there are no cameras, you can use the code. I have already uploaded it for you in the Teams. You can use it as a reference. Although all the questions in your exams are going to have the tables that you require. Okay, that's for the equation if you want to use the equations. Anyhow, AS is equal to M divided by 0.95 FY multiplied by Z. Did we calculate the value of M? Did we calculate the value of M? So M has been calculated. We just calculated M values. Do we know the value of the grade of steel? Do we know the grade of steel? Was it given in the question? It was given in the question that it's 460. Right? It was given in the question that it's 460. Remaining for me is the Z value. Remaining for me is Z value. So now we need to go and calculate for Z. So we return back to our sheet once again. I need to look for Z equation. So this is your Z. This is your Z, where Z is equal to D 0.5 plus. So we have Z D 0.5 plus under root of 0.25 minus 3 divided by 0.9. Okay. I just used whatever equation. Z D 0.5 plus under root of minus 2.5 minus K divided by 0.9. Are we okay? Are we okay till now? Okay. Another thing, they said for you that Z should not exceed 0.95 D. Okay, Z should not exceed 0.95 D. So we'll just, Fy is given in the question. Fy is 460. Fy is the grade of steel. Okay. So we can call this one to be Z1. And then we have another one, which is Z2, where Z2 is equal to 0.95 of D. Okay, so we have Z1 and we have Z2. Which one to be taken? They said for you, if Z1 does not exceed if Z1 does not exceed 0.95, then it's fine. Once again, they said Z should not exceed 0.95 D. So if it's lesser than 0.95 D, means it's fine. If it's more than 0.95 D, it's not fine. Are we okay? If it's lesser than 0.95 D, we are going to take it as it is. If it's more than 0.95 D, we cannot take it. We will be taking instead of it 0.95 D. To keep it short for you, we are always going to take the lesser of the two. From Z1 and Z2, we are going to take the lesser of the two. Okay. From Z1 and Z2, we are always going to take the lesser. Okay. Now, Do we have all the parameters? Do we have this one? Did we calculate dx and dy? Did we calculate dx and dy? So we have it already. Did we calculate for k? Did we calculate for k? No. So k is missing. So once again, we need to return back to our equation. We need to return to our equation where k says for you that it's equal to m divided by FCU PD square. Okay. So k is equal to m divided by FCU PD square. Now, did we calculate for m? Do we have the values of m? Do we have the values of m? So we have the values of m. FCU is the grade of concrete. Do you know how much is the grade of concrete? Is it given in the question? Do we know that the grade of concrete has been given? Not steel. The grade of concrete, which is T35. Grade of steel is 460. Concrete is 35. So it has been given. What about B value? Did you calculate B value? B is the width. How much did we assume the width of the slab? We said the slab is going to be designed for 1 meter width. Do you remember when we said 1 meter width? Do you remember when we said 1 meter width? So in this case, your B value is equal to 1 meter because that's your width. D. Did you calculate for D? Do you have the values of dx and dy? If we know m, f, c, u, b, d, can we calculate our value of k? Okay, so what we need to do, we need to calculate first k. After k, we are going to calculate z. After z, we are going to calculate as. Are we fine? K, z, and then as. Are we fine? Okay. Now going for the slides. FCU is the grade of concrete cushion. We said FCU is the grade of concrete, FY is the grade of steel. Now for area of reinforcement, we say the first thing that we need to calculate K value. After K value, we'll be calculating Z. After Z, we are going to calculate for X. So what we are doing right now, we are taking the first value of MX negative. Okay. Now we are taking FX MX negative. We are going to use K. Now, which moment we are going to use? If this is mx negative, then of course we should be using mx negative for calculation of k. How many moments were there? There are how many moments here? Leave the zero. Okay, leave the zero. How many moments are there? There are 4 moments. It means that how many k's are there? How many k values are there? For each k, there will be 1 moment. So we'll be having 4 k's as well. But 19.6, this is the moment value. To calculate k, we have taken mx negative because we are calculating for mx negative. FCU is the same, B is the same. Now instead of using dy, we should be using the corresponding d. Now if you are calculating for moment of x direction, then you should be using d of x. If you are calculating for y direction moment, then you should be using dy. Is it clear? FCU is fixed for x and y. B is fixed for x and y. M is changing for X and Y, D is changing for X and Y. Are we okay? Okay, so that's the first moment. The second moment, now you can see it's positive, mx positive. So once again, now we have taken the positive mx. Okay, we have taken the positive mx, and we have calculated the value of k. So we have kx negative, we have kx positive. Where you can see we have used dx, not dy, because both of the moments are for x. Now when we go and calculate for my, once again I'm going to use the same value, so my value here. Now instead of using x or the effective depth of x, we are going to use effective depth of y, because the moment calculated is for y. Are we clear? The moment of y will be resisted by the reinforcement of y. Moment of x will be resisted by the reinforcement of x. Are we clear? So you can see all over B and D are going to be the same. They don't change for x and y. M, we have values for x and we have values for y. D, we have values for x and we have values for y. So whenever you have different values, you should be choosing the correct one for the correct situation. Are we okay? Are we fine? Very good. Okay. Next step. Okay, next step. It says here, it says for us, we have K and we have K dash. We have K and we have K dash. If your K is lesser or equal to K dash, then no compression reinforcement is required, or it's singly reinforced. You remember you studied singly and doubly reinforced? K dash. Remember? Okay. Anyhow, it says for you, if your K is lesser than or equal to K dash is a fixed value, which is 0.156, then it's going to be singly. And just to give you a hint, always your slabs are going to be singly. If you are getting it to be doubly, then you have made a mistake somewhere. Your slab is always going to be a singly reinforced value, a singly reinforced slab. Okay, returning back here. Okay. We saw that Kx negative was calculated to be 0.029. It's lesser than 0.156. So this is singly reinforced for sure. Now after checking K, the next step, if you remember, is to calculate Z. We said K, after K is Z, after Z is then we have AS. Okay. We have Z. So Z1, that D into 0.5 plus 0.25 minus K divided by 0.9. Now, since we are calculating for X, then you should be using dx. Since you are calculating for Kx negative, you should be using Kx negative. The general equation says for you D and K. Now, since we have dx and dy, you should be using the correct one. Since we have Kx and ky, you should be using the correct one as well. Are we clear? Are we fine? Okay. So here, since we are calculating for x, it's going to be dx, and this is going to be kx negative. And we have calculated the value of z. But we said that there is z2 as well. Z2 is equal to 0.95. Z2 is equal to 0.95 multiplied by d. Now you are calculating for which d? Is it dx or dy? We are calculating for dx. Okay, because this is x, so we are calculating for x. Okay, so 0.95 into dx, 0.95 multiplied by 150 is going to give you this value. Now we said which one to choose. Are we choosing the bigger one or the smaller one? We should be choosing the smaller one or the bigger one. We said the smaller one. So which one to be chosen? We are going to choose Z2. The same process is going to be going for Kx positive. We check it with 0.156. For sure, it's going to be singly reinforced. We are going to calculate Z1 for it. We are going to calculate Z2 for it. And then we are going to choose the lesser of the two. Are we okay? It's a step only. You need to know the equations. And the equations are there for you in the DS code. Are we okay? Now in your test number one, of course, you will not have this much of calculation. Okay, in test number one, you will not have this much of calculation. It's half an hour only. Okay. After calculating for Kx negative and Kx positive, we are going to calculate now for Ky negative. So once again, we check it with 0.156, Z1, Z2. We check the minimum of the two. So we have taken it. And then Ky positive. You remember that we have 4 betas, means 4 Ks. It means 4 As. So Ky positive 0.013 lesser than 0.156. So it's singly reinforced as always. We found Z1, we found Z2, and then we are going to choose the lowest of the two. Now you can see the only thing changing between the equations is the value of K and the value of D. Previously, we were using dx whenever it was kx. Now it's ky, so that's why we're using dy. Once again, the moment of x is to be resisted by reinforcement of x. The moment of y is to be resisted by the reinforcement of y. So everything should be corresponding. If you are using x, then everything is related to x. If y, then everything is related to y. Are we okay? Any question till now? Once again, these are steps to be followed. Whatever you have done in design one was the same, but in design one you had only one key, 2 Zs, and then one As. Now instead of having one key, you are having 4 keys, because previously you were having one moment in design one. Now you are having 4 moments or 3 moments, more than one moment. Same process, but a longer one. Are we okay? Are we fine? Now we have calculated K, we have calculated Z. The second step is what exactly? The second step, or the third step, is going to calculate AS. We said K, after that Z, after that we are going to calculate for area of reinforcement. Now, AS X negative is equal as whatever we have said, is equal to MX negative 0.95 FY, which is 460, multiplied by ZX negative. And we have got the value, which is 315. So it's a direct substitution of the values. Are we fine? Okay. After ASX negative, you will be calculating, or you will be checking for the minimum. Okay, you will be checking for the minimum. The minimum reinforcement according to the code is 0.13% of the cross section. Okay, is 0.13% of the cross section. From where did you get it? From the code. We'll go to the we'll go for table of contents. So this will be with you. It's going to be with you. Now we have minimum and maximum area of reinforcement. So we have minimum percentage of reinforcement. We are going to click on it. It will open for us this table. Are we designing for tension or compression? We are designing for tension. So we have case A, we have case B, and then we have case C. Where case C says for you it's a rectangular section in a solid slab. This minimum should be provided in both directions. Now, are we using 250 or are we using 460? Are we using 250 or 460 for this problem? 460. So how much is the percentage which is minimum? The minimum percentage is going to go as the minimum percentage is 0.13. Okay, the minimum percentage is 0.13. It's there. Abdurrahman is there in the teams. So 0.13. Here we have got the 0.13.
Where, Mr. Where?
You didn't see it in the table, or you mean the book?
In the book and the book.
The book in the teams. I have uploaded it for you last class, right?
I don't. When I download it, it is not open.
Yeah, I see. After the class, I see.
Okay.
This is the extract. I told you in the last classes, I told you the BS code is so huge, and I told you we are going to use extract, which is summarized, and I have uploaded for you last class. Okay. So we have minimum AS 0.13.
Mr.
Yeah.
Can you repeat how did you get the minimum AS?
From the table, Bushra. This is the table. If you have the bigger code, okay, if you have the full code, you can find it in area, minimum and maximum area of reinforcement. This is the full code. Normally, I don't recommend students to use it because a lot of things are there. This is the minimum reinforcement where it says for you for tension reinforcement rectangular section in solid slabs, it's going to be 0.13%. Okay, that's page number 86. Are we okay? Are we fine? Okay, very good. Yeah, the class is uploaded over there. You can find it there as well. So we have ASX negative. Sure, I told you. I'll open the extracts later on. Just wait. Okay. So we have minimum AS 0.13%. Okay, 0.13% multiplied by B multiplied by D cap according to the code. So B is the width. Our width is 1000 and our depth is 175. So you can see that our AS is more than the minimum. So we are going to take our AS. You cannot take something lesser than the minimum. The minimum is the lower value to be taken. And then we have done the same. or ASX positive. We calculated AS. Minimum AS will never change for ASX or ASY. It's going to be the same. Because we are using D capital, we are not using D small. D small can have X and Y. D capital is only 1. Okay, so once again, 238, 227. We are going to use 238. It differs from a code to another code. Some of the pages in your codes are deleted, that's why. So it's better to use the extracts. It's better to use the extracts. Okay. So 13.36. Just wait for me till I finish from the problem. I'll open for you the extracts and I'll explain for you everything. Okay, do not confuse yourself with a lot of things. Okay, so we have ASY negative. Okay, ASY negative. We are going to have MY negative. Once again, the same process. The only thing changing the M value and Z value according to whatever you are calculating. So we have got ASY negative, which is 230. Minimum AS is 227. So we are going to take the largest of the two. Okay, we are going to take the higher of the two. ASY positive, we calculated it. It is 174, while the minimum is 227. So which one to be taken? Which one to be taken out of the two? Are we going to take 174 or 227? We are going to take, of course, the minimum because that's the lowest value to be taken. Okay, so it's 227. Okay. I'm going to stop. Okay, I'm going to stop here. We are not going to go for shear. There are certain things which are we covered now for your exam. Like, for example, this one. Now we call them at slabs at different level. I'll return back to the problem, but I need to finish this one since it's included in your exam. Okay, and it's easy for you to score marks for this one. Okay, so we have slabs at different levels. It means the slabs are not in the same actual level. So we have a regular slab and we have a slab which is having some services. Okay, we have slab which is having some services. We call this one as a sunken slab. Okay, we call it as a sunken slab. It's a slab which is having a lower level. It's sunk down. Okay, so you can see the level of the regular slab is different from the other one. It's different from the sunken slab. Are we okay? Are we okay with the sunken slab? Okay, so sunken slab is a slab in which you require water services like kitchen, toilet. This is the sunken slab. You can see that they are not the same level. They are not having the same level vision. Okay. Now, if you go and see, that's another example where the toilet and then there is a cantilever here. They are not in the same level. Not necessary. The depth is depending on the span. Suleiman, the depth is depending on the span of the slab. So they are not necessarily having the same depth. Okay. Now, how normally we say it? Now, if you can see here, this is the slab. Okay, this is a plan view. This is a longitudinal section. We can see now the left slab is sunk down and the other one is having a regular level. Okay, so this one is a sunken slab and this is a regular level. How would we know it? We know it by the hatches available. Okay, we know it by the hatches available. Okay, now if I open for you, Now, can you see this drawing? Can you tell me? Can you tell me which slabs are sunk slab? Can you slabs with Can you see the slabs with hatch? Can you see the slabs with hatch? Can you see them? These slabs with the hatch, okay, these slab with the hatch are going to be called as sunken slab. Are we clear? Are we clear? The slabs which are having hatches are sunken slabs. Are we okay? This is another plan. Once again, these are slabs. Which slabs are having hatches? What are the slabs which are having hatches? It's very clear. No, what do you mean by reality? Hatches? Bushra, it's sunk down. It is sunk down. Yeah, this is a drawing approved by municipality only. If you go to the municipality without showing your sunken slabs, it will be rejected directly. These are approved by Muscat municipality. If your drawing does not have sunken slabs shown, directly it will be rejected. Are we okay? Bushra, not a higher level. It's going to be lower level. Toilets are always going to be lesser. They are going to be not lesser, but lower in level. Now, when we talk about toilets and kitchens, where are the pipes for the water? Bushra, where are the pipes for the water? We have pipes, right, for the water? If you see this picture, you can see that this is the regular level. Now, for me, in reality, when I go and see them, I see both of them are having exactly the same level. In reality, okay, you go and see that both of them are the same level, but the slab level are not the same. This is the level of the first one. The other level of a sunken slab is going to be a little bit down. Why? Because we need to still place our pipes. If you go to any toilet while being constructed, you will see that the pipes are there. And I cannot keep the pipes above the slab, right? I cannot keep it outside. Is it clear? So this needs to be sunk down.
Sir,
Yes.
can you please repeat how we identify the sunken slab from the plan? Because the net connection was weak.
The hatch slab. Slab which is shown by hatches only. Okay. If you open your plan, a slab which is having hatches, which is having lines, inclined lines, is called as a sunken slab. Are we clear? Bushra, are we fine? Spelling of the slab. Spelling of slab is slab. You know, in the name of the slab, sunken slab. We call it as a sunken slab. Okay. We call it as a sunken slab. This is another example. Now you can see here that the finishing level for both slabs are the same. Okay. The finishing level of both slabs are the same. Sunken, S-U-N-K-E-N, sunken slab. But eventually, the level of the slabs are not the same because still here we need to keep pipes. So whenever we are keeping pipes, we need to keep, okay, we need, you can see now the green color here. You can see the green color. This green color is a filling load. We need to fill material so we'll reach to the finishing level. So this is the initial level of the slab. We need to keep the pipes. After the pipes, now we cannot place the tiles directly on the pipe. We need to fill it with the material, either to fill it by sand or to fill it by a lightweight concrete. After that, we are going to put our soil. The blue circles here are representing your pipes. The green color is representing the filling materials, which is either soil or lightweight concrete. Now, a person will be asking, why do we have here a sunken slab, here a sunken slab, here a sunken slab, but this slab is not sunk? Now, of course, this will not be sunk because there will not be any water requirements. It's at the roof level. Are we okay?
Mister, can you repeat why the second one it doesn't have the sunken
Because
slab on top?
why do you have, from the beginning, why do you have sunken slab? You have sunken slab because you have or you require water connection, right?
Yes, Mister.
Okay, so do you require any water connection at the roof?
No.
Okay, so I don't need to sunk it. Is it clear? I only lower the level when there are pipes to be installed. Now for the roof, there is no toilet at the roof. So no need for me to make a sunken slab.
Yes,
Are we?
Mister. Clear now. Thank you.
This is what we call sunken slab. Okay, this is what we call sunken slab. You should know how to identify. Okay, you should know how to identify. Sir, does the sunken slab designed to carry additional load? Of course, since there is filling material, since you have kept extra soil or extra lightweight concrete, it's going to be considered as a loading. Okay. Anyhow, now I'm telling you that one question will be related to sunken slab. I'll be bringing for you a plan, and you should know where is the sunken slab. Okay. So I'm giving you now a gift for your exam. Okay. Now we have finished calculating of area of reinforcement. These are required reinforcement. Okay, these are the required reinforcement. Later on, we need to get the provided reinforcement on the extracts here. These are the tables. Okay, these are the tables. So for example, now we have got ASY negative as 230 mm. Okay, 230 mm. We said the diameter, if you remember the diameter that we have used from the beginning of the question, it was 10 mm. Okay, it is 10 mm. So for me, I need to go. So for me, I need to go for the I need to go to this table, which is said to be slabs and foundations. This is not available in the actual BS code. Okay, so slabs and foundations. We are going to pick diameter of 10. We are going to pick a diameter of 10, and we are going to see a value which is more than 230. So we'll go and search for a value which is more than 230. So now we can use 262 as provided reinforcement. Okay, we need to go and use 262 for 262 for your provided area. Are we okay? Are we fine? Okay. Now one way of finding your provided is through the table. Okay, one way of finding the provided is through the table. Another method is by calculating it manually. Now, after the quiz or after the test, I'm going to show you how would you calculate it manually. Now, that's not going to be included in your test. Okay. Now, we have finished today's session, but first I need to go and explain for you the extract. This is the thing that you are going to use. Today there will not be any tests. Okay? There will not be any pop-up quiz because we don't have sufficient time. Anyhow, I'm going to explain for you the extracts. This is going to be used by you. You can open it at the time of the exam. Now the exam I have told you. The exam is going to be having 12 multiple choice and filling in the question for part number A. For part number 2 or part B, there will be 2 questions. One is for 1 mark and the other one is for 2 marks. So 12 marks are for part A, 3 marks are for part B. Part A is going to be multiple choice and 1 answer question, 1 short answer question. Okay. All of them approximately are basic questions, but you need to concentrate a lot. Part B are having 2 questions. One of them is easy as well. The other one is somehow tricky. Okay, so we have 13 marks which are easy that you can get, and 2 marks are a little bit tricky. Okay. For the last question, which is 2 marks, you need to get with you white paper and you need to have a calculator and a pen. You need to calculate. Okay, once again, most of the questions you can answer them by a calculator, except this. You can go back. You can go back, but everyone is going to have different question at a different time. Okay. Anyhow, if we go and see, let me just talk to you about the extracts. Now you can see certain things that we have seen, like for example, durability requirements. We can click on the durability requirements. Whenever we click on the durability requirements, we'll see that there is exposure condition explaining mild, moderate, severe, very severe. No, you need to write only the final answer. Only you need to write the final answer. Okay. And then there is the cover for mild, moderate, severe, very severe. And if you want to write something, that's fine. But for me, I require only the final answer. Okay. No, only to write the final answer. Okay. And then we have the minimum dimension for the fire. So I have told you now from where you will be getting the covers. Okay. Now from where you will be getting the tables for the slabs and whatsoever. We have here slabs. You just click on it. It will give you the one-way slab. It has been written clearly continuous one-way slab. So this is the table of one-way slab. This is the table of simply supported two-way slab. This is two-way continuous or restrained as we call it. Okay. So everything you can get from the table of contents. Okay. From the table of contents, you should be able to find everything. Another thing to be taken, like this is the formulas. So the formula that we are using, you can get it from here. So you don't need to memorize the page numbers. If you open the title, if you open your table of contents, you can click on whatever title and then it will take you directly. Okay. So here you can see the equations that we have used today. Another thing what you want to see, what things we have studied. We have studied this one, if you remember. Do you remember the 7-20-26? 7-20-26, do you remember this? Do you remember 7-20-26? Okay. And then do you remember this? Where I have explained you from where we have got our modification factor and other things. So these are related to deflection. Remember, these are deflection requirements. For the meantime, I think this is what you have studied only. One-way table, once again, you can go here. Since it's a slab, you need to search for slab from table of contents. So we have the slabs here. We have slabs, and the slabs we have continuous one-way slab. We have simple supported two-way, and then we have two-way continuous string. So you can click on it, and then it will open for you. It says for you clearly continuous one-way slab, and this is the table for continuous one-way slab. What is CBS now? C.B. No, normally beam, I told you, beam is a member that is normally designed for beam and shear and then checked for deflection only. Okay, so you don't require to use a modification factor. Modification factor is used for the deflection purposes. Asma, what is C.B? You mean continuous beam or what exactly? What do you mean? Both of them. You can use any code book which is available, but I would recommend you to use this one. Why would I recommend you to use this one? This is 28 pages only. That's the first thing. Second thing, you can use the table of contents directly to go to whatever page you want. But it's up to you. You can use whatever code book you want. As long as the values are the same and it's VS code only, not any other code, it's fine. Anybody is having any other question?
Mr. Which time in the Sunday?
We said that it's the same time class. The 10, we said, I think we said 2:45 or 2:15 to 2:45, right?
Okay.
This is there, I have mentioned it, I believe. Okay, now if you can see this one, the updated extracts are here. Abdurrahman, can you see?
Yes, Mr. No. I can see it.
Okay, so you can see it here. It should be opening for you, I believe. You can go and download it. Okay, you can go and download it. It's available.
I downloaded it now.
Now related to your yeah. Once again, you are not required to open your camera. Just for those who were not there from the beginning. And I have told you here when is going to be your test. Once again, test is going to be part A and part B. Part A 12 marks, part B 3 marks. 12 questions in part A, each one of them is 1 mark. 2 questions in part B, one of them is 1 mark, the other one is 2 marks. You will be having multiple choice, writing the short answer only. There is no definition. I don't bring definitions. There will be calculations. Most of the calculations you can do. Most of the calculations you can do using the calculator, except I believe, except the last question, which is part B, the question for 2 marks, where you need to have a paper. It is, I believe, it's the only tricky question. Others, I think I have covered them in the class. What else? Yeah, you will be having a lot of pictures as well in your quiz. Those who are having any other class, they can leave. There will be a lot of pictures as well, so be prepared.
Mister, the exam is gonna be on e-learning.
Yes.
Mister, like
Mister,
for
I
yesterday's
can.
test,
One by
faced
one.
some.
One by one.
I
Yesterday,
cannot do the exam now.
Which exam?
Pop-up quiz.
I said for you today that there is no pop-up quiz.
Okay.
Yeah.
okay, Mister, we had a problem for the part B questions that there is like a box where we should type. It doesn't appear for some of the students. So there is no any way to submit the two questions for part
No.
B.
For me, for sure, it will come.
Inshallah, I hope because it was really a problem yesterday.
No, because I tried it many times and it's appearing.
Okay, thank you.
Any other questions? No need for you to do the quiz today. I told you it's not required. You can open codebook during the exam list, even in the physical. Previously, in your design one, you are using the VS Code, so you can use it. Anyhow, there are no direct questions coming from the VS Code. Yeah. Okay. Now, Bushra, there are 50 other students in the class. Okay. Anyhow, so for the sentence lab, I said very clearly related to water connection and sewer. Other connections like electricity and whatever, we have them normally in the water. We don't have them in the slab or beneath the slab. Zahara, you can use the online code book. The tables will be available in the question, but you can refer to your code book as well. It's up to you. All the questions are having the necessary tables. Whatever table you require for solving that particular question will be available for you. Except for the last question. Any other questions that you have?
Sir, the question could be from the previous examples that we solved it, a part of it.
You mean the pop-up quizzes?
No.
And
Test.
the pop-up quizzes, you mean? The one you solved in the what you call while having the class?
No, sir, I mean the test.
Which test? Have you taken any test till now?
No, I'm asking you, sir.
Okay.
It could be, the question could be from the previous examples that we solved it, but a part of it, right?
Anything is possible. You can get some, maybe you will get some questions that I have already solved for you. Maybe you will not get them. It depends. There are many questions are there, so it depends on your luck what to get, what not to get. You are not going to get the same questions where your other friend is getting. Okay. Okay. Thank you very much. See you in the quiz time. and enjoy the remaining days. Best of luck.